Hello everyone, I am Dr. Priyanka Kaushal from Chandigarh Group of Colleges, Landra. Today, the topic of my talk is measures of dispersion. We come across in statistics this topic of measure of dispersion. First of all, let us go through the contents first. We'll discuss about the introduction, about the term, that how the measure of dispersion is affecting our data. Secondly, we'll discuss about the types of the measure of dispersion, the range, the semi-interquartile range, and finally, we'll conclude it. Measure of dispersion. It is actually the spread out of the data. If we plot our data along a curve, we see at times our data is spreading out. At times it is the narrow down. So, measure of variation gives us information on the spread or variability of dispersion of the data values. If I ask you, by looking at these two graphs, what do you observe? Which of the distributions of scores has the larger dispersion? Obviously, you can see here the upper distribution is spreading out more as compared to the below one. That is why they are less similar. So, measure of dispersion, if we talk it theoretically, if they are more the similarity between the data set, then lower the measure of dispersion would be. It has an opposite connection. Again, if it has less similar, the scores are to each other, then the higher the measure of dispersion will be. In general, more spread out a distribution is, the larger the measure of dispersion will be. Now, talking about the types of the dispersion. Mainly, there are three types of the measure of dispersion. One is the range, second one is the semi-interquartile range, and variance or standard deviation. Range. Range tells us if we have the data set, just picking up the smallest value and the largest value. The difference between the two is the range. You can see from this example, along the number line, I have mentioned some of the data set, and these green balls are depicting their frequency of occurrence. So, range is the largest value minus the smallest value. Smallest is 1 and largest is 13. If we take the difference of these, we get 12. That means range is equal to 12. But do you think so that is justified? Just by looking at the edges, the extremities of the data set, can we decide the dispersion, the range? Actually not. Let's take one more example. Why the range can be misleading? It ignores the way in which data are distributed. You can see first case, I have taken 7, 8, 9, 10 and 11 once only. In the second case, I have taken 7, I have skipped 8 and 9, and instead of that 8 and 9, I have taken 12 3 times. Why? Because I want to keep the number of entries of the data set equal. But even if these are equal, what happens? Range is coming again out to be equal, that is 5. Can we see here that even though these two are not here, but still range is giving us the message that it is still 5. This way, range can be misleading. Now, it is sensitive to the outliers. How? If one set of data is 1, 1, 1, 1, you can see the repetition of 1 mentioned here, then 2, 2, 2, 3, 3, 3, 4 and 5. So range would be only the largest value minus the smaller value. That is 5 minus 1 equal to 4. In another case, if I take 1, 2, 3, 4 and all of a sudden I jump on the largest number equal to 120. So what would be the range? That is the difference again between the largest value minus the smaller value. This time it is 119. Not keeping in consideration that it has taken a wide jump from 4 to 120. So due to these certain reasons, the range can be misleading. That is actually the measure of dispersion is more accurately considered in a way when we calculate the quartile measures. Quartile, which have 4 parts, which divide our data set into 4 equal parts. It shows like this: 25%, 25%, 25% and 25%. We name it by the initial capital letter, that is Q. One is Q1, Q2 and Q3. This Q2 is well known as the median. Median is the one which divides the whole data into 2 equal parts. So here you can see that Q2 is doing the same. So this Q1 is the first quartile and Q3 is the third quartile. What happens when we see them with the theoretical aspect? It says that the first quartile, Q1, is the value for which 25% of the observations are smaller and 75% are larger. Similarly, Q2 is the same as that of median, as I have just mentioned, that 50% of the observations are smaller and 50% are the larger ones. It is changed when we are talking about Q3. Q3 shows that only 25% of the observations are greater than the third quartile. So this is another point of view looking at the problem. Now let's discuss about the formulation. What is the formula behind that? How do we calculate from a data set the quartile? Let me take capital N as the number of observation. So first quartile position can be depicted by n plus 1 divided by 4. 4 divided by, because it is being divided in 4 equal parts. And here second quartile position, that shows n plus 1 upon 2. Third quartile position is 3 times n plus 1 upon 4. We discuss this in the coming up example here. For that example, we have taken one ordered array in which numbers are arranged in the increasing order, and the numbers are 11, 12, 13, 16, 16, 17, 18, 21 and 22. Number of observations are 9. If we are calculating Q1, Q1 shows us, suggests us n plus 1 upon 4. So n is 9 here, 9 plus 1 upon 4, that means to say 2.5 position of the rank data. So that means to say our quartile lies somewhere here between 12 and 13. What would be that value? That is 12.5, and thus Q1 and Q3 are measures of non-central location, whereas Q2, which is the median, is the measure of the central tendency. Carrying forward the same example, we will be calculating Q2 and Q3 for the same. The same example is again here. We have taken n equal to 9, and this is 2.5th position, which suggests us to be 12.5, and for Q2, which is n plus 1 divided by 2, that means to say 5th position, and looking at the 5th position, this is 1, 2, 3, 4, 5. 5 means to say 16 is at the 5th position of this very data. So we have taken that Q2 is, which is so called the median, is equal to 16. Then comes Q3. Q3 is the third quartile, for which the formula stands to be 3 times n plus 1 divided by 4. So this time it is coming out to be 19.5. It is between, it is taking the 7.5th position, and we look at the 7.5th position, that is 19.5. Now, there are certain calculation rules associated when we start calculating quartiles measures, because the main concern is the n, which is the number of observations. That n, if the result is a whole number, then it is rank position to use. As the rank is coming on that position, it is the moment to decide that yes, it is the relevant quartile that time. But if it is the fractional half, then average of two corresponding data values to be taken. And in a case when it is not a whole number or a fractional half, then round the result to the nearest integer to find the ranked position. So these are the concepts we come across when we take different kind of data set, where we come across some fractional, some integers, some whole numbers, and then we decide that what sort of rule will be applied. So, interquartile range. The interquartile range is Q3 minus Q1. By this time, we are very well aware that what was meant by Q1 or Q3. Interquartile range suggests us that take the difference of these two. So, this IQR is Q3 minus Q1 and measures the spread in the middle 50% of the data. The IQR is a measure of variability that is not influenced by outliers or extreme values, as was mentioned in case of range. That is why quartiles give us better interpretation, better results as compared to range. Measures like Q1, Q3 and IQR that are not influenced by outliers are called resistant measures. So conclusion is, when to use the range? The range is used when you have ordinal data or you are presenting your results to people with little or no knowledge of statistics, because range is quite misleading. That is why when to use the SIR? The SIR is used with the skewed data, as it is insensitive to the extreme scores. When there is lot of variability is there, where a lot of there is no symmetry, then in such a case skewness is there. For skewness, you have a negatively skewed data or positively skewed data. In all such situations, going with SIR is the best option.